Hello and welcome to our third revision lesson. We're going to be looking at the first part of chapter 9, which was length, area and volume. Firstly, complete this do now task, working out either the area or the missing length of the shapes drawn. Pause the video while you work through them. Okay, checking answers then. The first rectangle, the area is 15 centimetres squared. The second rectangle, the missing length, is 3 centimetres. The first triangle, the area is 40 centimetres squared. Remember, we have to do base times perpendicular height divided by 2. And then the missing area for that second triangle, missing length, is 4 centimetres. Okay, parallelograms. A reminder that the area of a parallelogram is the base multiplied by the perpendicular height. Remember, perpendicular sides are at a right angle to each other. So for a parallelogram, the height we're looking for will be through the middle. We won't be using the two sides. We need to make sure our units are consistent. So we'll be using 6 centimetres and the 65 millimetres. Make sure you convert one of those. I'm going to convert to centimetres. So I'm going to be doing 6 multiplied by 6.5 to give us 39 centimetres squared. For the area, we did not need that 7. Okay, have a go at these 4. Pause the video while you work through them. Right, question 1, 24 centimetres squared. Question 2, 16 centimetres squared. Question 3, 15 centimetres squared. And question 4, 20 centimetres squared. Next, trapezia. So that's the plural of trapezium. This is the formula for the area, half of a plus b times by h. Here's a trapezium. Now a and b are the parallel sides, and in this diagram they are labelled with the arrows. And h is the height, but that will always be perpendicular to the parallel sides. So we've got some lengths labelled. We're not going to need that 5 centimetres. So if we fill in, a and b are 7 and 13, h is 4. Remember to use the rules of BIDMAS when you are working this out. So the brackets will be 20, so half of 20 is 10, and then multiply by 4 to give us 40 centimetres squared. Have a go at calculating the area of these trapezia. Right, let's check the answers. Question 1 is 30 centimetres squared. 2 is 40 centimetres squared. 3, 24 centimetres squared. And question 4 is 28 centimetres squared. We're going to have a look at a bit of both now. So if we just have a quick reminder, the parallelogram area is base times perpendicular height, and the trapezium area is half of a plus b times by height. You're going to have a go at calculating the missing sides. So pause the video while you work through these. Okay, question 1, 3 centimetres. Number 2, also 3 centimetres. Number 3, 7.5 centimetres. And number 4, 4 centimetres. Okay, having a look at circles then. So a reminder that the circumference of a circle is pi d, so pi times diameter, or 2 pi r, so 2 pi times the radius. And it will depend what you're given to what you will use. The area is pi times radius squared. So let's have a look at a couple of examples. So here on this circle we are given the radius, which is 4 centimetres. So to calculate the area, I'm going to do pi times 4 squared. I'm going to round all my answers to one decimal place, so I get 50.3 centimetres squared. For the circumference, I'll use the formula 2 pi r because I've been given the radius. So I'll do 2 times pi times 4, and that gives us 21 centimetres. Remember, the circumference is a length because it's the perimeter of the circle. Okay, if we're given the diameter, we need to half the diameter to get the radius. So for area, it will be pi multiplied by 2.5 squared. And that is going to be 19.6 centimetres squared. And the circumference, we'll use the formula pi d this time because we're given the diameter, so we will be doing pi times 5, which is 15.7 centimetres. Okay, you're going to have a go at calculating the area and the circumference for each circle to one decimal place. So pause the video while you work through them. Okay, the first one. The area is 78.5 centimetres squared and the circumference is 31.4 centimetres. Going across, the second one, the area is 28.3 centimetres squared and the circumference is 18.8 centimetres. The third one, the area is 12.6 centimetres squared, the circumference also 12.6 centimetres squared. You've got the same value there because when we are doing pi times diameter, or think of it, if we use the 2 pi r, 2 times the radius gives us 4, so 2 times 2 is 4, but 2 squared is also 4 from the area. So that is the circle that gives us the same value for the circumference and the area, although they're different units, so it's not technically the same size. And then the last one, the area is 153.9 centimetres squared and the circumference 44.0 centimetres. You've got to have the 0.0 to show that you've rounded to the required degree of accuracy. Okay, let's have a reminder of arcs and sectors. So these are fractions of a circle. So the area of the sector is theta over 360. So remember, theta is a Greek letter which we use to represent angles. And then the 360 comes from the full degrees in a circle. So this is our fraction of a circle times by the area of a circle. Then our arc length is the same idea, theta over 360 times, this time, the circumference 2 pi r. So here's an example. We've got a sector. Let's work out the area. So we're going to use 170 because that is the angle we are given, and then the 15 was the radius. So this gives us 333.8 centimetres squared. The arc length, again we're going to use 170 over 360 and then multiply by 2 pi r, and the radius again was 15. We get 44.5 centimetres. If we were asked for the perimeter of this shape, you've got to remember that arc length is only that curved part. So for the perimeter we also need both radii. So we're going to have to add on 30. So the perimeter is 74.5 centimetres. Okay, using those formulae, you're going to calculate the area and perimeter. So just be careful there, I want perimeter, not the arc length of the following sectors. Round all of your answers to one decimal place. So there's 4 questions there. Pause the video while you work through them. Okay, let's check the answers. Question 1. For the area, first of all, we have got 13.1 centimetres squared. Question 2, 14.1 centimetres squared. Question 3, 22.1 centimetres squared. And question 4 is 28.1 centimetres squared. The perimeters now. Question 1 is 15.2 centimetres. Question 2, 16.7 centimetres. Question 3, 18.8 centimetres. And question 4, 24.0 centimetres. Okay, moving on to slightly more challenge with this topic, we're going to have a look at how to calculate the angle. So if we're given the area and the radius, we want to be able to calculate the angle. So here's a reminder of the formula. Let's substitute in what we know. So we know the area is 17.45. We don't know theta. Pi is a constant, it's a number that we're given. And r, the radius, is 5. So we're going to solve this equation. We want to get that theta on its own. So we'll aim to first of all get theta over 360 on its own. So we're going to divide by the area of a circle, which if we simplify we get 25 pi. So we're going to divide by 25 pi. Now you could work that out and get a value, but we don't want to round our answer too early, so we're going to leave it in that format for now. Finally, to get theta on its own, we want to multiply by 360. So this is what we'll type into our calculator, and this will give us our most accurate answer. And then round it to the nearest degree, so we're going to get 80 degrees. The principle is exactly the same if you were given the arc length. You would just have 2 pi r instead of pi r squared. So you're going to have a go at some questions where you calculate the angle to the nearest degree. Here's 4 questions for you, 2 where you're given the area, 2 where you're given the arc length. Pause the video while you work through them. Okay, let's check the area questions first. So theta is going to be 98 degrees, and the second one, theta is 248 degrees. The arc length questions, the first one, theta is 69 degrees, and the second one, theta is 336 degrees. So well done if you got those. Those are a little bit more tricky. Okay, the next thing we are going to recap is the volume of a prism. So a reminder, the volume of a prism is calculated by doing the area of the cross-section multiplied by the length. So here's an example. So the cross-section is the part of the shape that is the same all the way through the length. It is exactly the same area all the way through. So either you will have a shape that you need to calculate the area of, or you will be given that area. It might be that you're given the volume and you need to work out the area or the length. So you're going to have a go at calculating the volume of these shapes. So calculate the cross-section, so the area of that front face, and then multiply it by the length. So pause the video while you work through these. Okay, that first section, question 1, you've got 30 centimetres cubed. Question 2, 15 centimetres cubed. Question 3, 18 centimetres cubed. That second section, question 1, 60 centimetres cubed. Question 2, 72 centimetres cubed. And question 3 was 54 centimetres cubed. Hopefully you noticed on this second section, the first one was a parallelogram for the cross-section. The second one was a trapezium for the cross-section. The third one was a compound shape. You needed to split it into 2 rectangles. Or you could have done more rectangles, but the minimum was 2. Okay, let's have a reminder of the volume of a cylinder then. So because a cylinder is a circular prism, it's the area of the cross-section times the height. So pi r squared times height. So here is a cylinder. To calculate the volume, we're going to do pi times by 8 squared times by 30, which to 1 decimal place gives us 6,031.9 centimetres cubed. You're going to have a go at some. You're going to give your answers to 1 decimal place. The first 2 are calculating the volume. The third one is to calculate the height. So you're going to have to think backwards and show you're working to solve this. And the fourth one is to calculate the radius. So pause the video while you work through these. Okay, the first question then. We should have 502.7 centimetres cubed. The second one is 78,539.8 centimetres cubed. For the height, we're going to have 12.6 centimetres. And lastly, for the radius, we're going to end up with 3.4 centimetres. So well done if you got those last 2, especially the radius question. For questions like this, if you're unsure, what you could do is then use the answer you've got and substitute it into the formula for volume to check you get the original volume. But remember, you've rounded your answer, so it won't be exactly the same. And the final thing for this session is to recap the surface area of a cylinder. So a reminder, the surface area is 2 pi r h plus 2 pi r squared. So the 2 pi r h, that's the curved part, and the 2 pi r squared is the 2 circles. So here we go, here's an example. We're going to substitute the values into the formula. So we've got 2 pi times 3 as the radius, times by 10, which was the height, plus 2 pi times by 3 squared. Let's work that out, and we get 245.0 centimetres squared. That's been rounded to 1 decimal place. You're going to have a go at some. Again, round your answers to 1 decimal place. The first three are to calculate the surface area, and the last one is to calculate the height when you're given the surface area. So make sure you write down all your working for that because you'll find it much easier. Okay, pause the video while you work through these. Okay, let's check answers. The first one, the surface area is 653.5 centimetres squared. Going across the second one, the surface area is 14.7 centimetres squared. The third one, the surface area is 1011.6 centimetres squared. And the last one, well done if you got this, the height is 17.5 centimetres. Okay, that's it for this topic, or this lesson. So the topics we'll cover in the next revision lesson are going to be pyramids, cones, frustums, and spheres. Okay, see you next time. Goodbye.